So in this short video, I'm going to do some supplementary uh, notes on uh, solving system of linear equation. So let me quickly share. So we have seen that there are various methods like Gauss elimination method or Gauss-Jordan method, etc. Then we had Gauss-Jacobi method and also Gauss Seidel method, sometimes called Gauss Seidel method. So this is matrix based, so we have done it, but I'm quickly going to look at the distinction between this and this. So let's take an example. That we are solving is the following. Let's say we have a system of equations 2x1 plus x2 plus x3 equal to 5. 3x1 plus 5x2 plus 2x3 equal to 15. 2x1 plus x2 plus 4x3 equal to 8. So in the elimination method or Gauss-Jordan method, we just take a matrix, but the other two methods, we just have a set of equations. Like, for example, this equation 1 can be rewritten as x1 equals 1 by 2 times 5 minus x2 minus x3, right? So this x2 goes as minus x2, this x3 goes as minus x3, this 5 as it is, and this 2 is the quotient here, right? So similarly, x2, this time we are going to take equation 2, not 1. From equation 2, we'll extract what is x2. That is going to be 1 by 5 times 15 minus 3x1 minus 2x3, right? And for equation, for extracting a formula for x3, I'm going to use the third equation. And by this, what we get is 1 by 4 times 8 minus 2x1 minus x2. So this Roman 1, Roman 2, and Roman 3, these are the equations that will help us now. Now, the prescription for Gauss Seidel method and Gauss Jacobi method is similar, that we start with an initial guess. But what is the difference? I'm going to tell you shortly. So guess, some initial guess. So we'll just start with 0, 0, 0. Okay, it's not a hard and fast rule, but you can even start with 1, 1, 1. But let's go with this. So notice that you could, by trial and error, look at some solutions. What might be the solutions? Just think about it right now, and what might be the values for x1, x2, x3, which will satisfy all three. Just try to make a trial and error, but that is just to have fun in this example. But let's see how it goes. So when I put 0, 0, 0, this is 0, this is 0. So x1 will be 1 by 2 times 5 minus 0 minus 0, which is 5 by 2, which is 2.5. Now the interesting thing is that while in Gauss-Jacobi, when we go to x2, we still retain these values only, these x1, x2, x3. But here we immediately update. because my x1 value has come as 2.5, in this x2 formula, I can substitute x1 as 2.5. But x3 we have not yet computed, so x3 still remains as 0. So immediate updation is 2.5. So 1 by 5 times 15 minus 3 times 2.5 minus 2 times 0. This turns out to be simply 7.5 by 5, which is 1.5. So this is the distinction between Gauss-Jacobi and Gauss Seidel method. So let's go to x3. The same Roman 3 you see here. This formula I'm going to use 1 by 4 times 8 minus, see what is that? 8 minus 2x1 minus x2. So now x1, x2 both are computed. So no need of resorting to the original guess. We'll use 2.5 and 1.5. So 2 times 2.5 minus 1.5. Right? So it can be approximated, although there is a decimal after 0.4. So I'll approximate it as 0.4. To be very exact, what it comes is 8 minus 2 times 2.5 minus 1.5. I'm going to compute it and divide by 4. Divide by 4. 0.375. But I'll approximate it as 0.4. Okay. Okay. So we got this x1, x2, x3. What I call this is only first iteration. Okay. Now we'll go to second iteration. Again, we get a set of values for x1, x2, x3. Now x1 is equal to again 1 by 2, 5 minus x2 minus x3. What is the latest x2? 1.5. What is the latest x3? 0.4. Turns out that this value is 1.6. I'm not going to show the calculation. Let me be very quick. X2 equal to, as we have seen, this value 1 by 5 times 15 minus 3 times 1.6. That is the latest value. Is that the, yeah, the latest value of, yeah, the very, just now we did 1.6 and minus 2 times, while here we had taken 0, now we have to take the latest value 0.4. This turns out to be 1.9. So we got x1, x2 in the second iteration. X3 equal to 1 by 4, 8 minus 2 times, what is the latest x1? 1.6. What is the latest x2? 1.9. And that turns out to be 0.7. Now I'll try to tell you my insight. See, in first iteration we had 2.5, 1.5, 0.4. We can't still guess what is the actual answer. But now you see the x1 value is coming down to 1.6. X2 value has gone up to 1.9. So x2 value is going up, x1 value is coming down, and x3 value is slowly rising. Right? So my guess is that Well, because I've solved it several times, so it's not just my guess, it's the right thing. So ultimately, you'll get x3 as 1 and x1 also as 1, and this will slightly inch up to 2. That is what is going to happen. Okay, so if you want, you can substitute and check it out. The actual answers are 1, 2, 1. Okay, so we will see how we reach it. I don't think I'll have time to do entire thing, but so third iteration. Third iteration. X1 equal to again 1 by 2, 5 minus what is the latest x2? 1.9. Latest x3 0.7. 5 minus 1.9 minus 0.7. This turns out to be 1.2. You can check it. These two minuses are like 2.8. 5 minus 2.8 is like 2.2 divided by 2 is 1.1, I guess. See? So, as I was guessing, this is coming down to the final iteration will give you 1. I'll not do, I'll stop at the third iteration, but you see it's 1 only. The actual answer is x2 is 1 by y 15 minus 3 times. The latest x1 is this one, certainly 1.1 minus 2 times latest x3 is still the older one, 0.7. Yeah, so this is 1 by 5. This is like 3.3. This is 1.4. So 3.3, 4.3, 4.7. So 10.3 by 5. It's roughly 1 second. Yeah. So 5 2s are 10, 0, 6. See, I did tell you that x2 is ultimately going to be 2, but now we're almost there. X3 equal to 1 by 2, 8 minus 2 into 1.1 minus 2 into 2. What is it going to be? I'm not able to go to the next sheet. 1 minute. This technology is sometimes risky for me. Yeah, what is happening? Yeah, I'm sorry. So x3 is 1 by 2, 8 minus 2 1s are 2, 2 1s are 2 minus 4, which is 8 minus 6.6. So 1.4 by 2, which is 0.7. This is the same thing. We are not, x3 is not changed much. Yeah, so If you continue this, continuing this, we get maybe after another 2-3 iterations. Well, in the next iteration, I did get x2 very close. X1, yeah, x1, x2 very close, but x3 was still a little away. So to get exactly at least 3 iterations we have to do. So we get x1 is equal to 1, x2 is equal to 2, x3 is equal to 1. This is a right answer. I'm not saying that you should get exactly the same, but almost like 1.00 something. This is 2.00 something. Like this, you will get the answers close to this. Okay. So that's all about some supplementary uh, practice session on Gauss Seidel method. So please stay tuned to this. I'll also do some more practice exercise because these numerical methods require a lot of practice. So please stay in touch with this channel. Okay, I'll